Hello students, how are you? Today I present for you about vector addition, subtraction and multiplication. Let us see one by one. A vector in general represented by a graph. A vector can be decomposed into two components, x and y components. Uh, in your mathematics, you already know about x and y axis. This is the x-axis and this is the y-axis, the vertical. Uh, for example, this vector A is equal to 3i plus 4j, where I is a unit vector uh, along x-axis and j is the unit vector along y-axis. The length of I and j is 1 because a unit vector uh, has its value 1. So let us see the sum of two vectors. Uh, for example, we have different cases. If vector A is perpendicular means 90 degree to a vector B, then A plus B will be represented by, this is a vector with B vector, no, sorry, then the resultant vector is represented by C, then the resultant vector is calculated by C square is equal to A square plus B square plus twice of AB cos theta. That means because for perpendicular vectors we simply use C square is equal to A square plus B square, but here it's written that parallelogram. This can be found by using parallelogram. C vector square is equal to A square plus B square plus twice of A B cos theta, where theta is the angle between vector A and vector B. But here we have perpendicular. Perpendicular means 90 degrees. That means the value of this, that means for perpendicular, this is the signal, perpendicular case, C square is equal to A square plus B square plus cos, sorry, uh, sorry, this co twice of A B times cos theta. Now this implies the value of C square is equal to A square plus B square plus twice of A vector plus times B vector times cos 90 degree. By default, cos 90 degree is equal to how much? 0. It's cos 90 degree is equal to 0. Then for the perpendicular case, this value become what? 0. So left only C square is equal to A square plus B square. That's why for perpendicular case we use the resultant vector is equal to C square is equal to A square plus B square. Now For example, here we have vector A has the value 3 and vector B has the value 4. 4. Then, what is the value of vector C? The value of vector C can be calculated by C square plus A square plus, no, C square is equal to A square plus B square. That means just substitute all the values. A 3 the whole square plus the value of B is equal to 4 the whole square, which is equal to 9 plus 16, which is equal to 25. Then the value of C is equal to the square root of 25, which is equal to 5. Good. The next topic about if vector A is not perpendicular to B. Vector is not perpendicular to B, we use parallelogram method. The diagonal C for the parallelogram is the vector sum of vector A and vector B, already known. By using a triangle method, or move the vector B to the head of vector A. That means, for this vector, we have the head, okay, and the tail. So, move vector B. Vector B means this one is moved to what? The head of vector A. That means this already goes to the head of vector A. Then we have this figure and we have the resultant vector C. So vector B is moved to the head of vector A. Now if the angle between vector A and vector B is, let's say, the angle between vector A and vector B theta, then C square is equal to A square plus B square plus twice of AB cos theta, because here the angle between A and B is not perpendicular and which or not perpendicular. So we have example. Let's say vector A is equal to 3 and vector B is equal to 4, and the angle between vector A and vector B is 60 degrees. Then how to calculate the resultant vector? The resultant vector can be calculated by directly substituting all the values of these to this formula. C square is equal to, what is the value of A? A is 3 the whole square times, plus, sorry, B square, B, the value of B is equal to 4 the whole square plus twice of A times B into cos theta 60 degrees. This equal to 9 plus 16, because 4 square is 16, plus twice times A 3 times B 4 times cos 60 degree. Oh, sorry, cos 60, it's already 1 over 2 or 0.5. Let's write here 9 plus 16 plus 2 times 3, 6 times 4, 24 times cos 60 is equal to half, 1 over 2 or 0.5. The value of C is equal to, sorry, okay, its value is equal to the square root of this one, this is equal to 37. C is equal to 30 square is equal to 37. This implies, let's come here, and then c is equal to the square root of 37. This already the approximation. Let's say because 6, let's say 6 times 6 36. Okay, it's already 6 point around 0.8. Okay, that's the value of the resultant vector. Okay, the next point, if the difference of the vector a and b, that means the subtraction part, that means for example here we have vector b. Look, we represent vectors on the graph. Vector b is towards the from the x y, then this side it's positive for the x and negative side. So the vector b is towards the negative side. Look the direction, and vector a towards the positive y. That means we have uh, vector b is towards the left or the negative side. Due to this reason, we have negative b. So uh, the resultant vector will be or can be calculated by using parallelogram, but the value of v of vector b is negative. Okay, the value negative. That means let's bring the equation of parallelogram method. C square is equal to a square plus b square minus plus twice of a b cos theta. But the value of b is negative because of its, look, when we put its value on the xy plane, its value is negative. Okay, then which is equal to c square is equal to a square plus b minus b the whole square plus twice of a into minus b cos theta. C square is equal to a square, already a square, b minus b the whole square, or a negative number is multiplied by itself, its result is positive, means plus b square. But here 2 times a minus b, how much? It changes the value, multiplying in your mathematics, multiplying a negative number with a positive number will make the equation negative. That means due to b value negative, we have we change the positive, this positive change it to negative, negative twice of a b cos theta. This is the difference or the subtraction of the vector. So we represent in general vectors on the xy plane. Okay, and check the direction because they are scalar points. The next point is multiplication of vectors. Here we have two types of multiplication of vectors. The first, the scalar. The first one is the scalar product, and the second one is the vector product. The scalar product, we call it dot product, or the dot product is the vector is also called the scalar product. Okay, they're the same, scalar, or we can't say it dot product. The resultant of the dot product of the vector is a scalar value. Dot product of vector is equal to the product of the magnitude of the two vectors and the cosine of the angle between the two vectors. The resultant of the dot product of two vectors lie in the same plane. The resultant in the same plane. Look, it's found on the same plane. The resultant vector, for example, here it's found on the same plane of the two vectors. The dot product may be positive or negative number. and and its formula. The dot product of two vectors a and b can be written as a vector dot b vector is equal to the absolute value of a times the absolute value of b vector times cos theta, where theta is the angle between vector a and vector b here. Uh, the second one is the cross product. Cross product in general is called cross product. In general, is called the vector product. Okay, cross product is a form of a vector multiplication performed between two vectors of different nature or kinds. When two vectors are multiplied with each other and the multiplication is also a vector quantity, then the resultant vector is called the cross product of two vectors or the vector product. The resultant vector is perpendicular to, note down here, the resultant vector is perpendicular to the same plane containing the two given vectors. It's perpendicular to the two given vectors. But in the case of scalar product or dot product, the resultant of the dot product of the two vector lie in the same plane. Okay, don't forget that. So here is vector a and vector b, and the cross product here is the cross product. Okay, not the x. Okay, so we can understand uh, this with an example. If we have two vectors lying in the xy plane, then their cross product will give a resultant vector in the direction x-axis, which is perpendicular to xy plane. The x, the x, the x, the x symbol is used between the original vector. The vector multiplication or the cross product of two vectors as shown as a cross b is equal to absolute value of a times absolute value of b times sine theta. But in the case of uh, dot product, we have a dot b is equal to absolute value of b, no, a times absolute value of b times cos theta. That's the difference. And what does it mean x, y, z axis? In general, we have this, and the resultant vector is perpendicular to the xy plane, or this is the resultant vector. For example, we have this, the blue one. Oh, sorry, let me change the color. I not uh, I don't have not, mm, 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 the blue one. This the blue one is perpendicular to the y and x axis. So this xyz plane, they are perpendicular to each other, okay, 90 degree, 90 degree, 90 degree, all. Okay, that is all about today's lesson. If you have any question, please write down on the comment. Until then, next time we will start motion. Thank you. Bye bye.